So this topic, we're going to be using grouping method when we actually are going to be doing what we call the AC method. So I think this is a really important topic. That's why I'm throwing so many sample questions at you, is because not only am I going to be using this grouping method for 4 terms, I'm secretly going to use it when I do the arch method, the AC method. So here's another problem that I have 1, 2, 3, 4 terms. Now I know some of you are saying, wait, can't I combine these two and then it becomes negative 13x? The problem with that is the grouping method must have 4 terms. So you don't want to combine these like terms. Keep them as 1, 2, 3, 4 terms for us to do the grouping. What we're going to do is anytime that it's 3 terms in the arch method basically will stretch it out to actually make it look like 4 terms. So we'll talk about that later. For right now, notice we have 1, 2, 3, 4 terms. But before I do the grouping method, you should always know, anytime I'm factoring, always look for a GCF using all 4 terms at once. So, 1, do I have matching set of parentheses? No. 2, do I have the same letter in all terms? No, we have a constant here, so no. Do I have a common number factor? Well, I know I can do a tree diagram for here and here, but let's look here at the end. 5, you know you can't break that down because that's just 1 and 5, so we'll leave it as 5. And 3, you can't break that down, it's a prime number, it's just 3. So if these guys don't have anything in common, it doesn't matter that these might also have 3s. If this one doesn't have a 3, then I can't do anything. Okay? And then the D, or the 4th part, does it start with a negative? No. So I did go through A, B, C, D. Every single question, go through your A, B, C, D to check to see if there's a GCF using all 4 terms. We now know we have no GCF. We're still going to use the grouping method. Remember, parentheses around the first 2 terms, parentheses around the last 2 terms. So the first 2 terms, and then the last 2 terms. Make sure you include the plus sign always in the second set of parentheses. See how it's scooped in the second set. Next, notice this is a mini problem now. So step 2 says take out the GCF just using the first set of parentheses, the first 2 terms. We see that, yes, there is a set of matching stuff available. We got the same letter, and we have the same number. Now you might be saying, wait, I don't see the number. Again, if you don't see the number, just do a tree diagram. To save some time, I'll tell you that 30 is 2 times 3 times 5. 18 is 2 times 3 times 3. So you can see they both have a 2 and a 3, and they both have the same letter X. So I know my GCF is 6X. Okay? Remember, you're going through A through D. I saw that they didn't have matching parentheses. Same letter, took out the smallest exponent, so there's the X. I saw that they both have a number in common. You could divide this by 6, you can divide this by 6. My GCF is 6. But it doesn't start with a negative, so I only had 2 out of the 4. Let me get my leftovers. Remember, the leftovers is just basically I'm going to divide each of these 2 terms by the GCF. Divide this by 6x. Divide this by 6x. You're going to get 5x. Here you're going to get a negative 3. Remember, the x's are tied, so there's no x's in this term. In the second set of parentheses, our step 3, see if there's a GCF. No matching parentheses. These don't match. I don't have the same letter in each term, because that 3 is a constant. I don't have a number in common, because 5 can't break down and 3 can't break down. And it doesn't even start with a negative, it starts as a positive. So what happens if you don't have a GCF? Well, here's our hint. Remember, in step 3, I said, hint. If there's no GCF, what you want to do is you want to use 1 as the GCF. So anytime there's not a GCF, technically 1 is the GCF. So I'm going to take out the GCF and say it's 1. By taking out as 1, remember, this sign I always have to bring down as part of the GCF. So my GCF is a +1. If I divide each of these terms by +1, you'll kind of realize it doesn't change. 5x divided by 1 is 5x. -3 divided by +1 is -3. The reason why I do this is because notice we do have matching set of parentheses, and we do have a GCF here, and we do have a GCF here. If you did not have this, then you might have thought that it's a binomial times a monomial. Your answers when you're done with the grouping method is always a binomial times another binomial. So once we see that these match, we know our final step is to take those matching leftovers and put it as just one set of parentheses. Okay? That's it. I didn't put any squares or exponents. I just said, ooh, I have 2. Now it magically becomes 1. And then the other set of parentheses, which must be a binomial, would be the GCF that I got here, and this understood GCF of +1. 6x + 1. If you did a square and did a 2 by 2 square, you would get this original answer. Right? So anytime you don't see a GCF, you went through A through D, call it a +1. And then you'll see that it'll still match, and then you'll have a +1 to make this a binomial.